Welcome everyone. This is the second of 3 videos on igneous rocks, and I'm just going to start with the same chart that we looked at in the beginning of the first video. Again, by way of review, igneous rocks represent those that have been cooled and usually crystallized from a hot liquid state. And the 3 textural classes that we're going to worry about in this class include crystalline rocks, glassy rocks, and pyroclastic rocks. Here's an intermediate crystalline rock that happens to be extrusive in origin. This is called andesite. And that volcano in Alaska is very typical of the sort of environment where andesite forms. Andesite is more enriched in silica than mafic rocks like basalt and gabbro, but less enriched in silica than more felsic rocks like granite and rhyolite. And this hand sample is very typical of what andesite often looks like. It has an interesting texture called a porphyritic texture. That's a type of crystalline texture characterized by a few large visible crystals, as you can see in the hand sample down here, surrounded by a sort of more numerous sea, if you will, of smaller, generally microscopic crystals. How would a texture like this form? Well, we have to consider a sort of 2-stage crystallization process for this rock. Let's imagine that we pick up the story in the magma chamber beneath a volcano where the magma chamber hasn't yet erupted. And so we know by now that when magma is deep below Earth's surface, it cools slowly. And we know by now that slow cooling leads to large crystals. So this is what's happening to create the large crystals that we see in this hand sample of andesite. And at a certain point, before the crystallization process is complete, before the magma solidifies totally, at some point the magma actually erupts to the surface and it spills out of a volcano to perhaps become an andesitic lava flow, or the andesite that's erupting out of the volcano might even be used to actually build up the volcano itself. And so when this intermediate or andesitic magma is erupting, it's erupting as a liquid crystal mush. You'll recall that the crystals formed before the magma erupted down in the magma chamber. And then when the magma erupts, it's now at or very near the Earth's surface. So the remaining magma cools very quickly to create the more numerous smaller crystals surrounding the larger crystals. So just to recap, what's interesting about this particular texture, called a porphyritic texture, is it's indicative of a sort of 2-stage crystallization. First within the magma chamber beneath the volcano, and then ultimately within or next to the volcano itself at the Earth's surface. And you can probably see as well that the overall color of the andesite, sort of a brownish, can be kind of a grayish color, sometimes a little bit greenish, but generally andesite is a little bit darker than rhyolite, but not as dark as basalt because it's intermediate in composition. So that means it's darker than felsic rocks, but lighter than mafic rocks like basalt. Here's gabbro. Gabbro is mafic in composition and intrusive in origin. And we can tell all that just by looking at this hand sample of gabbro. I can clearly see individual crystals in the gabbro with my naked eye. Each of these sort of color splotches would represent a separate crystal. So this is very much of a coarse-grained rock. There's a 2-centimeter scale bar. So these crystals in the gabbro are clearly visible. And even in outcrop, we can clearly see visible crystals. So overall, we actually know a lot of information just at a glance here. Because of the dark color, we know that gabbro is mafic in composition. And because of the large crystals, we know that gabbro is an intrusive igneous rock. And also because of the large crystals, we know that gabbro cooled slowly. Here's basalt, very similar to gabbro in composition. Both basalt and gabbro are mafic igneous rocks. But in contrast to gabbro, you can see in this hand sample that basalt is very fine grained. In this case, we can just barely make out the crystals with our naked eye. And certainly there are lots of crystals in this rock that we can't see at all. We need a microscope to see them. This is what basaltic lava typically looks like. This is a young basalt flow on the big island of Hawaii. And because basalt is mafic in composition, it has a pretty high color index. And so for that reason, it's pretty dark colored. And peridotite. Peridotite is quite rare in the Earth's crust, but we think it's essentially quite common in the upper mantle. Almost all of the upper mantle is probably composed of peridotite of some form. This happens to be a peridotite exposure in Scotland, and you maybe wouldn't know it from the exposure, but if you look at the rock up close, if it's a fresh piece of peridotite, very often it has an abundance of a mineral that you're familiar with by now. Let me describe it as olive green in color. Exactly, you probably would guess that the greenish mineral here is olivine, and you would be right. Typically, peridotite tends to be enriched in either olivine or pyroxene. But both olivine and pyroxene are dark colored minerals. And so this means that the color index of peridotite is very, very high, usually up around 100%. In other words, peridotite typically doesn't contain anything else but dark colored minerals. And because of the coarse grain size of this hand sample, again, that tells us two things. That tells us that the rock is intrusive, it formed deep underground, and it also tells us something about the cooling history of the rock, namely that this rock cooled very slowly on timescales of maybe thousands or tens of thousands of years as a result of being deep underground. So let's get some practice kind of naming and classifying igneous rocks using portions of that all-important diagram that you've seen. Okay, so in this case, I'm giving you a description of the rock, and I've asked you to name a fine-grained, high silica igneous rock, composed mostly of microscopic crystals. Well, because we know the rock is fine-grained, namely it contains mostly microscopic crystals, right away that tells us that the rock has to be extrusive. So automatically we've narrowed down the field to just these three choices. And then because the rock is enriched in silica, that tells us that it's felsic in composition. So felsic, extrusive, has to be rhyolite. What about this one? Name a fine-grained, low silica igneous rock. Here again, if you read the question carefully, you'll see that I embed the critical information in the description. I could show you a picture of this rock, I probably would on an exam, but technically you don't even need to see a picture of the rock to formally name it and classify it. I give you all the information you need in the description. So let's go through that briefly. Okay, the fact that the rock is fine-grained, again, tells you that it has to be extrusive in origin. And then in this case, because I also tell you that the rock has a low silica content, then we have to be in the mafic column. So mafic extrusive can only be basalt. Here's another one. Name a dark-colored, iron-enriched crystalline igneous rock with a low silica content and visible crystals. Let's work backwards. Let's work from the end to the beginning. Since the crystals are visible, that automatically tells us that we're dealing with an intrusive igneous rock. So it has to be one of these four possibilities right off the bat. And then because the rock is described as having a low silica content, we can immediately rule out granite. Granite, being felsic in composition, has a high silica content. We can also rule out rhyolite for a couple of different reasons. The silica content of rhyolite is high, not low, like this rock. And also remember that as an extrusive igneous rock, rhyolite is very fine-grained. And yet I've indicated that this rock has visible crystals. So in summary, the visible crystals tell us that the rock is intrusive, and the low silica content tells us that the rock is mafic in terms of its composition. So an intrusive mafic igneous rock has to be gabbro. Let's do one more concept check question. Name a light-colored, coarse-grained, crystalline igneous rock with a high silica content. Let's work forwards to backwards in this question. Okay, light-colored, what does that tell you? Low color index, has to be felsic in composition. So right away, from the crystalline nature of the rock and from its light color, we know that it has to be either granite or rhyolite. And then in this case, the rock is described as being coarse-grained. So that tells us that the rock has to be intrusive in origin. Felsic in composition, intrusive in origin, can only be granite. Okay, I think we'll stop there, and I encourage you to keep going and watch the third video in this series.